Nigel Unwin arrived at the LMB in 1968 to do a postdoc with Hugh Huxley in the Division of Structural Studies. After developing a totally original phase contrast microscope, he followed that up by improving the resolution of electron microscopy from the 20 angstrom to the 7 angstrom level. In collaboration with Richard Henderson, this major advance resulted in the spectacular breakthrough publication in 1975 of the first structure of the membrane protein bacteria rhodopsin. After 7 years away from the LMB at Stanford, Nigel returned in 1987 as joint head of structural studies, before becoming the first head of the new Neurobiology division in 1994. His long-term interest in how electrical signals are transmitted throughout the nervous system gave rise to another scientific tour de force, the refined 4 angstrom structure of the torpedo ray acetylcholine receptor, the first near-atomic structure of an ion channel in a native membrane setting. Nigel's work throughout his career has been characterised by great originality and powerful reasoning, combined with outstanding experimental skill and thoroughness. And unsurprisingly, he's received numerous awards. Notably, he's a Fellow of the Royal Society and a past Croonian lecturer, and a Louis Jeantet Prize winner. Welcome, Nigel. Thank you very much for coming to talk to us today. I want to start off almost at the beginning, I guess. So you're a New Zealander, and you did a first degree in engineering at Otago School of Mines. So how did you get from there to Cambridge?
I wanted to continue an academic career, so I wrote letters to lots of institutes around the world, and it turned out that Cambridge offered me a PhD. So I got on a boat, took 4 weeks and got here. And actually it turned out the guy that offered me a PhD, Professor Cottrell, he's a very sort of famous guy, and he became Margaret Thatcher's chief scientific advisor. And by the time I got there, he was gone, so somebody else took me on, and he was very keen on electron microscopy of metals, which I was very keen on too. So that worked out really well.
So you did a PhD in metallurgy and then switched over into biology and came to the LMB, which sounds quite unusual. What prompted that?
Well, I was always interested in biological things. I sort of had that sort of upbringing. I had lots of pets. My grandfather was a surgeon, my father was a paediatrician, so there was that side of things. And in metallurgy, actually, they'd been looking at metals with the electron microscope for about 10 years. They're seeing fantastic new things, dislocation, stacking faults in metals and all that. And by the time I got there, I felt to some extent the field was the discoveries had already been made. You could make more discoveries by sort of changing the alloy composition and seeing what you see, but nothing really great. And then the other thing was there are a lot of very clever people in that field, and I sort of knew I couldn't compete with them, really clever. So I've always tended to, I've got a rather small brain and tended to keep away from people like that. And I thought going into biology would be a good idea. It's a sort of softer science and things are a bit easier there. And well, I didn't quite know how to go about it, but one or two people in the end told me I should go and ask Hugh Huxley, because he went from a physics career to biology, and so I arranged an appointment to talk to Hugh. And Hugh was really nice, told me all about biology, and I told him about how I loved using the electron microscope looking at metals, and I thought it'd be more interesting to look at things like viruses and muscle that he was working on. And But we just left it at that. And then about actually a week later, Hugh phoned me up and said, would you like a job with us? And of course, that sounded great to me. And he said, what he'd like you to do is to try and improve ways of visualizing biological specimens. At that point, they were using a negative stain technique. Do you know that? Where you sort of put the heavy metal salt around the biological specimen, and it's really the salt that you see rather than the specimen. And the sort of limitations, you really wanted to see the specimen itself. And Hugh had the insight to think that, there were ways of getting around that, and maybe I could do that.
So were there things that you brought with you from your PhD that they'd never heard of before then, in terms of technology and new techniques?
No, I'm afraid not.
So it wasn't quite the exciting thing that you were hoping for, or?
Well, I was sort of a bit of a lost soul when I first came, actually. It was totally new to me. It was an exciting environment. Of course, that was in the early days with the lab was very small, and, there was Crick and Perutz and Sanger and Kendrew.
So you hadn't really got away from all the brilliant people there.
No, not at all. Yeah. So I was completely mistaken there. But, Hugh was very kind in giving me this job, and I really was determined to make the most of it. So I set about trying to find ways to improve things, and I succeeded, I guess, in the end.
Yeah. So you stumbled on a way of doing phase contrast microscopy. Is that right?
Oh, that was one thing. That didn't. In the end, I mean, the idea is you put something in the microscope that ends up giving you a lot more contrast, rather than like a phase plate in a light microscope. I sort of thought that might be the way to get around negative stain. Just look at the biological thing with extra contrast. And I was sort of playing around with putting wires in the beam, and I sort of that would improve the contrast, because most of the beam goes straight through the specimen, and all you see is everything so bright. So if you put a wire in the beam to cut out the direct electrons, you should see more contrast. And I sort of worked out that you needed a very fine wire to do that, and it was actually quite, and you have it over a small aperture, about 30 microns in diameter, and getting a very thin wire over an aperture that size is not so easy, and then you have to stick it with a glue on either side. And what I thought might be a good idea was to use spiders' threads instead, because the threads are already sticky, so you didn't have to worry about gluing them. And I found out that I spent a long time looking at spiders' threads, and big spiders make thick threads, and they're actually made up of strands of smaller threads. And I found that with very, very small spiders, just a little bit bigger than those money spiders, those little. I don't see them now, but there used to be lots of them around about 50 years ago.
I guess there's no money now either, so.
Don't know what it is, but anyhow, we had a shed in the garden where there were some very small spiders, and their threads were incredibly small, thin, so you couldn't see their threads actually, but you could, if you held the spider up, you could see the spider, and so you knew that there was a thread there.
So how on earth did you collect them?
They were just hanging around in the shed. But I found a way of actually getting the threads to go over these very small apertures right in the middle. And I found a way of getting the conductivity right to produce phase contrast, and that was coating them with gold. And it turned out to produce beautiful contrast from the specimens.
What is slightly blowing my mind is that you're treating this like it was a completely normal thing to be doing. It seems to be extraordinary that you could go from seeing a money spider's invisible thread to getting it covered in gold and onto your microscope. Was that the sort of thing you did in those days?
No, it wasn't really. It was a sort of act of desperation. You know, I'd been struggling away at the LMB and not really understanding what people were saying. I mean, I didn't know anything about biology.
Yeah.
And Hugh, I liked Hugh a lot. He was a very distant supervisor. I never talked to him about what I was doing, and I think my research, maybe we talked about it once a year at the most. But he was great in that he was doing his own thing, you know, dissecting frogs and sticking things in the X-ray beam. You know, so I did my own thing. And, you know, I just got into a rather desperate state, and that made me turn to spiders. And it actually worked very well. It produced beautiful images, but the thing is they didn't last very long in the electron microscope because they had poor vacuums in those days, and the threads would very quickly get contaminated, and then you couldn't use them anymore. So that was one thing that was wrong. And of course, it was actually really tricky to use, so it never caught on. But fortunately, a bit later, then I was trying to freeze things in ice. I actually didn't succeed. You know, Dubochet succeeded in freezing things. I got things in ice, but I didn't get beautiful pictures like he did. And in the end, I sort of gave up. But I found that you could, instead of using water, you could use something like water, which is glucose or sucrose, and that didn't evaporate in the microscope vacuum. So a lot of specimens were quite happy if you just put a bit of glucose there, and that actually helped me and Richard get the structure of Bacterodopsin. It was the purple membrane which Bacterodopsin is in. I was very happy in glucose. So, although the first technique was useless, it gave me some credibility in the lab. I remember giving my first lab talk, being very scared with all these guys in front. You know, there was Fred Sanger, Sidney Brenner, and Max Perutz, Aaron, and Hugh. And of course, I didn't actually quite understand everything that I'd done, but it did give a good result, beautiful pictures, and they were all very excited about it.
I guess beautiful pictures are always quite persuasive, aren't they?
Yes, I think that's right. Yeah. That was a lucky break, actually.
So was there a point at which you stopped feeling like an outsider and decided that you were comfortable at the LMB?
Well, yeah, I think so, gradually. It took time, actually. I mean, I had a lot of difficulty with talking to people because I couldn't understand what they were talking about, and I wouldn't. Well, you know, I rather avoided going up to the canteen, and you know, it's the thing you should do because I wouldn't have anything to contribute.
Yeah.
I also, actually, the way I do research, I'm usually by lunchtime, I'm absolutely frustrated because the thing's not working, and no mood to talk to anybody. Maybe afternoon tea I'd go up for that. But actually, that time the lab was so small that everybody sort of knew everybody, and there were lots of parties, and I went to all the parties.
So you've referred to working on Bacterodopsin with Richard, but I actually want to ask you more about your ribosome project. So that was kind of the first attempt of the LMB to put a bit of flesh on the bones of Crick's ribosome ideas, or is that not a reasonable way of thinking about it.
Well, the way I thought about it, I know when Francis Crick was, doing things with the genetic code, he said that you should put ribosomes in a black box. Now's not the time to look at them. They're too complex. We should look at the other aspects of the process. But, in everybody's mind, the ribosome was a key thing to look at. And, it's quite big, so easy to see in the microscope. So I was always interested in that. And what actually happened was that after our structure of the bacteriodopsin, we felt that this is a great technique. We can use it for lots of other things. But they needed to be, those days, it's not like single particle cryo-EM now, they needed to be in some sort of crystalline order. And one day there was a News and Views article in Nature which showed a picture of arrays of ribosomes that looked just the ideal thing for our approach. And so I wasn't going to let that go. The ribosome was important. Here's a chance to make a real big breakthrough. And so these were from the oocytes, the unfertilized eggs of lizards that lived in lizards. Can I show you that?
Yeah,
lizards.
no, absolutely. So this is where we come to the item that you brought along. Actually, two items that you brought along. So,
can you see that there?
Yeah.
And can you see the other side? You can see the ribosomes sitting on the endoplasmic reticulum membranes, those sort of edge-on views of these crystals. Anyway, it wasn't straightforward because I wrote to the guy, Carlo Today was his name, in Naples, who was working on them. In those days you didn't have email, so I sent him a letter and I got no response, and I sent him another letter, no response. So I decided what I had to do was get on a train to Naples and knock on his door.
Unexpectedly.
Absolutely. No, yeah. And there he was sitting in his office smoking his pipe. And it turned out he was a very nice guy, and I told him the idea of looking at these, and he was very supportive and apologised for not, of course he was about to write and all that sort of thing. And I can't actually remember the details, but I think when I left Naples, I managed to have about 5 or 10 lizards with me in a box.
And how big were these?
About that long, I think.
Oh, right.
Yeah, the big ones, fully grown about.
So
that
you
long.
brought them back on the train from Naples to
Yeah,
Cambridge.
so that got me started.
Yeah.
But of course, the 5 lizards, so I started to look at the oocytes then, but 5 wasn't enough. So I think I did return to Naples a couple of times. The way Carlo got the lizards was from children. I tried to catch some when I was there. Of course, I couldn't catch a single one. They paid the children to catch the lizards for them.
So these were just the common and garden lizards knocking around in
They're
Naples.
all over the place in Naples,
Yeah.
but they don't live north of Rome.
And there's something special about that particular species that this happens. You can't use other lizards for...
That's a good point. It only happens in the winter when they hibernate. It's some sort of storage thing. And of course, we did start getting lizards. In fact, I certainly brought over a box of 100 myself once, and then somehow Michael Fuller, who's amazing at organising things, arranged it so we had quite a regular import of lizards, and hundreds at a time.
And they were still coming from Naples, caught by the local children, you think?
Yeah. I don't know whether Michael sort of organised the payments or what.
Yeah.
And of course, They only occur in winter, so the lizards in the middle of summer don't have them. But I found out quite quickly that you could put them in the cold room for a month, and then they would make these crystalline ribosomes. So, so in the end, I got a nice three-dimensional map from the ribosomes, but it was very poor resolution. I think one of the lowest resolution maps you could get, sort of 60 angstroms or something like that. But I was able to write a paper in Nature explaining how they sit on the endoplasmic reticulum. In the old textbooks, they used to have them with the large subunit sitting, this is the membrane, sitting on the membrane, and the small one on top. And actually, they weren't like that at all. They were sort of almost sideways on the membrane. So it was a new thing, and it got into the textbooks, which I was pleased about. And of course, I had a good relationship with Carlo today, and he came over here, and we did some things together. And there's another funny thing, because his pipe, I mentioned his pipe. He, of course, insisted in smoking his pipe in the lab, and that set off the fire alarms. And we had fire engines, and it happened several times because he so, instinctively uses his pipe. And as soon as he did,
and it's slightly surprising, given that everyone else was smoking cigarettes at the time, that a pipe
that's
should.
Right. Yeah.
Yeah.
Certainly they was. Yes, it's smoking in the lab with cigarettes. Yeah, that's right.
Yeah. And the upshot of all this is what you've got behind
this
your
thing
lizard
there. Yes.
photograph,
That's a tetramer of ribosomes.
Should we tip it round
Where's
this way?
the membrane would be? The membrane would be like that. They'd be sitting on the membrane like that. And that little hole there is sort of between the subunits. So you can see them, they're sort of lying more or less flat on the membrane, with the large subunit actually making contact.
And this is something that is contemporary to when you were doing this work, or is that?
That's the way you used to do maps like that, contour maps, and you place them on successive layers.
So that's actually printed layers on.
You have it comes out of the computer and printed output, and then you put a bit of glass over with a black pen and draw the contours.
So it's hand-drawn contours.
Yes.
Individual layers being built up.
Yeah.
Wow.
And then you, just to highlight the really densest parts, you put a bit of grey sticky stuff on.
It's a bit different these days, I guess, isn't it?
Isn't it? Yes.
But that's an absolute work of art. It's beautiful.
Yeah, it's quite a nice little story, and then I was really happy with it.
So were you working on that just by yourself? Or did you have help? Is that something you prefer then, to work on your own?
I'm afraid, well, I can tell you more about that, but I do love working by myself, and or with one other person. Like with Richard, that was a lot of fun. It's better working with another person because I think your two brains is better than one, and you can sort of check everything out. But it's a lot of fun in discovering something yourself.
So Aaron Klug once said about you that you had the gift of putting the unexpected to use. So do you think this is why you've been so successful at these technological things?
I think that they're basically, I try the obvious things and they don't work, and then these are acts of desperation, like the spider's thread or the glucose. I did work really hard and just tried. I was really driven because I wanted to somehow prove myself to Hugh that I was worth being kept on. I noticed you said that I was a postdoc. It was never clear to me that I was a postdoc, actually. I thought I was a technician. He didn't... The post wasn't defined.
So you didn't actually have a contract or anything like that?
I had a contract, but I had no idea how long it lasted or anything.
Oh, really?
I felt pretty vulnerable to getting kicked out at any particular stage, and we sort of never discussed things like that.
Yeah, I guess you didn't have PDRs in those days to discuss your progress, especially if he only spoke to you once a year about your work. So
Yeah.
yeah.
Well, my point of realization that I must have been some sort of postdoc, a staff member, I suppose, was that once after these things had worked out really well, Hugh and Aaron grabbed hold of me in the canteen and sat me down and said they thought I needed a technician. So I must have been a staff member then, I suppose.
So
I'd been there for a long time.
And you had no idea that was the case?
Yes, and I had no thought about getting a technician. So that was very surprising. They were very supportive. The thing is, then getting a technician, of course, that means sending out an advertisement and interviewing people. And Aaron said, well, we'll do the interviews together, because he knew that I didn't have a clue how to interview somebody. So that was really nice. And I got a person, Ron Milligan, and it worked out very well. We worked together, and when I went to Stanford, he went with me.
Oh, right. Yeah. Yes, I want to move on to that, actually. So what is it that made you decide to go off to Stanford?
Well, one thing, of course, I was looked after a lot by Aaron and Hugh, and they're almost like fathers to me, and I felt, I should, and I knew LMB was rather a special place. I should really go out to the big world in a competitive environment and see what I can do there. Aaron told me that, what you should do in life is you should follow your genes. You have genes for doing this well, you have genes for doing this badly, and concentrate on the things that you're good at and just keep the other things aside. And because I didn't quite know what I was good at, I thought I was quite good at doing experiments, but I thought, maybe I'm a great lecturer, good at writing grants and things. So that was one reason for going there. And the other really important reason was I was very taken by Lubert Stryer. He recruited me there. Do you know that?
He wrote Stryer Biochemistry. Yeah.
Yes.
Yeah.
Yes. And he was, since very early on, he was very much saying that he wanted me to come to Stanford. He'd set up a new cell biology department there, and I dilly-dallied for 2 or 3 years. And in the end, he said, we've got everything set up for you. And then I sort of felt I more or less had to go. And of course, it was that was right. It was a very good experience.
So completely different from here, I imagine, if you were teaching and much
completely different. There's a lot of sort of cutthroat stuff there. You had to sort of defend your space. Yes, a lot of teaching. I had to teach medical students, and they sort of evaluate you after your lecture. And
did you turn out to be an excellent lecturer?
well, they weren't. I wouldn't say I was really excellent. I mean, they had some. Lubert Stryer was an amazing teacher. But yeah, they thought I was pretty good. I was pretty pleased, actually. I mean, they could be quite rude. They say, this guy's really nervous and he needs to tell a few more jokes or something like that. I wasn't good at telling jokes, but I seemed to get the message across. And then writing grants, which was a new experience, and I found that a good experience, actually, because I felt it made you sort of focus your thoughts on what you should be doing next. And it was quite fun when the money came in. and of course the teaching, I taught histology, and which included neurobiology. I thought that was really good. It made me really understand a whole lot more about what biology is about, because teaching medical students, which you need to spoon feed, it means you need to know things really well. So preparing for the lectures, it was a lot of work, but in the end it gave me a much better background to biology.
So you went from being terrified of going to the canteen here because you didn't know any biology to lecturing medical students at Stanford on it.
Yes, I did. Of course, it was very stressful, but I guess in those days I could manage the stress. In fact, I've been able to sort of say to myself, in life you go through, you can look on life as going through different phases. And, I was looking at that as, I look back now on the Stanford phase, which was 7 years, the sort of grant writing and teaching phase. And I don't, I think it's really good. I don't have to worry about teaching anymore. I've done my bit. So.
And so this was where you first got interested in neurobiology and acetylcholine receptors then?
Yes.
So how did that come about?
Well, there's two things. One is, of course, it seemed to me, having had a broad introduction to cell biology through my teaching, that understanding how nerve cells communicate with each other is absolutely important. You need to understand that in depth before you're going to understand how the brain works. That was one thing. And another thing, I was lucky in having a postdoc come called Alain Brisson, who he wanted to do he's doing a structure of bladder membranes with, the same methods that we use with bacteriodopsin. But it turned out that I saw a paper published that it wasn't on the acetylcholine receptor, but the protein had the same sort of symmetry as the acetylcholine receptor. And that told me that previous work on the acetylcholine receptor that had been done was totally, I felt it was totally wrong. And I managed to convince Alain about this. And the important thing is Alain had worked on the acetylcholine receptor when he was in France as a PhD student. And he got these tubes from torpedo rays that had sort of crystalline arrays of acetylcholine receptors. So, crystalline arrays, and now somebody's got it all wrong. The published papers I could see were all wrong.
Wrong in terms of what?
They had the structure wrong. They didn't understand the symmetry. They had tubular membranes as well, but they got it from the torpedo californica, the Californian version of this fish. I could see that they got it wrong because you needed to take pictures with a low dose to see the symmetry properly, and they hadn't done that. And so I convinced Alain that we should have some torpedoes at Stanford and work on them. So that got me into working with the torpedo rays, and sure enough, we looked at the structure and they were wrong, and so we were able to publish a couple of papers correcting it and seeing for the first time what the acetylcholine receptor really looked like.
Is it very exciting when you get these insights into new structure then that no one's ever seen before?
Yeah, well, it is. Yeah, of course it is. That's why it's nice. I feel it's always nice to share things with somebody.
How does this manifest then when you see something wonderful? Do you run up and down the corridor shouting, or just share it with the other person?
No, but it keeps me going to, on to the next project. I think it's obviously one wants to do something really brilliant. I mean, I think we all do, don't we? And I've been lucky enough to work with good colleagues and find some nice systems like that lizard and the acetylcholine receptor, which you can, really make discoveries from.
So you came back here in 87? Is that right?
87.
As head of structural studies?
Well, yes, of course this wasn't my idea at all. I thought I could just come in and continue like I'd left off.
And how soon after that did the idea of having a new neurobiology division come up then?
I think when I returned from Stanford and probably spent a little bit more time in the canteen than I used to, I sort of, to let my views known that neurobiology I thought was the science of the future. I mean, Francis Crick went over to the Salk Institute in 1977, and he went over to try and understand consciousness. And a lot of people, Aaron in particular, is very influenced by Francis. He seemed to know what the things to do were. And when I was at Stanford, they were just starting a neurobiology division, and all the excitement, scientific excitement in the US when near the end of when I was there was all around neurobiology.
So it was kind of your idea then, or Aaron's idea?
I think we both felt it was important. Aaron, he seemed to take too much notice of me actually when he thought, I've been to Stanford, I'm a grown-up man now. Anything I say must be okay. So it was funny. It was very much like a father-son relationship. The son's now left school and he's... So we discussed it a bit, and I remember we had a meeting with all the heads of divisions about should we create a neurobiology division and how should it be done and what should my role be.
And did you want to be head of division?
No, I didn't want to be head of division, and it didn't. It wasn't a clear-cut thing at all. I told you just very briefly what I understand happened. I think the Neurosciences Board would not have been happy with me as head of division. I was seen as too much of a sort of amateur. I didn't really have neurobiology credentials. I was working on the acetylcholine receptor, but I was really a structural biologist. And also, I'm not the most articulate guy, sort of, not a leader type guy. So the idea was, well, the Neurosciences Board will set up a search committee and identify a whole lot of potential neurobiology leaders, and then we'd meet together with me and Aaron and the Neurosciences Board and discuss all their potential guys. But in the end, they decided on this chap called Eve Bard. I think with Aaron's guidance, I had to write a letter saying that the way to start this off would for you to be a joint head with me, so that you got the feeling of how things are done at LMB. And that may be the reason that he didn't accept her. At the last moment he pulled out. So what happened then? The sort of fallback position was that somebody in LMB would sort of look after the neurobiology division until they came across a proper leader, which may turn out to be in a few years' time from one of the people that we recruited, an obvious leader. So I got to be sort of head by default, sort of, I wasn't chosen really to be head.
So did you set out to create a particular sort of ethos for the division? Did you think about how you'd like it to, and divisions here have very particular personalities, don't they?
Yeah,
So
yeah, they do.
Did you think of what personality you'd like for neurobiology?
Oh, I didn't think of it quite in those terms, but I had some fairly strong views actually. I definitely wanted it must be distinct from cell biology, although we use some of the same tools. And I felt it must incorporate structure things because that's what we're so good at LMB. And I had another thing I thought was really important was a lot of communication. And I think for the first few years, we always had group meetings between the guys we'd recruited and me and everybody every 2 weeks. Because, when you're starting something up, there's bound to be things going wrong and you really want to nip them in the bud. And the other thing I really felt strongly about was I'd been through a lot of recruitment at Stanford. Lubert was trying to build up the cell biology department, and sometimes it seemed like almost every week we'd have a new visitor, give a sort of job talk, and then we'd sit around, discuss them afterwards and say, he's no good. And it just sort of went on like this. It went through everybody. And maybe I'm exaggerating a bit, but nobody seemed to be quite good enough. And I didn't think the cell biology at Stanford really thrived as a result. And I felt with neurobiology, we'd been given these near 20 posts. And one thing we must do is not be too fussy. We're not going to get the very best people because there's no reputation that we have. We've got the LMB's reputation, but not in neurobiology. So it was really, really important to get people. So the idea was to get the best we could with several sort of recruitment drives, and then realise that in 5 years' time, these would be career track appointments. We would have to sort of sift them out. And then, then the other aspect was this communication was to make sure that everything that was done together with the Neurosciences Board and together with representatives from the other divisions. So when we had people that we thought we would recruit for career track, we made sure that the other divisions felt that was okay and the Neurosciences Board felt it was okay. So there was a lot of work but a huge amount of communication to make it go. And this is the first 5 years, sort of getting it started.
How long did you last as head of neurobiology then, given that you were somewhat reluctant?
Well, I lasted for 10 years on my own.
Yeah. Was that longer than you wanted, or was it okay in the end?
No, it was longer than I wanted. The idea was, I think Michelle Godet became joint head in would it be 2003? Yeah, and I had the idea that I could just last one more year. So a 10-year thing, but it certainly lasted a bit longer. As I say, I actually was doing a lot of collaboration with people in Japan at that time. And I see on my passports, I used to go over there and use their microscope for 10 days at a time. And I counted the number of stamps to Japan on my passport, and guess what the number was? 72.
72?
Yeah.
Oh.
So...
Over a period of how many years?
5 years or so.
Oh, gosh.
No, maybe it was 10 years, actually. It must have been more than that. It worked out that I've spent more than close to 2 years in Japan altogether. Not seeing anything because I was just going to a dark room there.
Yeah, I guess you could escape from administration
Yeah, well,
if you were
that's
in a
right,
completely
because-
different country.
yeah.
So
Yeah, and they did have email then. I didn't have to write letters.
Oh, excellent. So then you went back to just working more or less by yourself after that then, or?
Well, yes. Hugh Pelham, the previous director, made me an emeritus quite early on. I didn't want that, but I think when I had a contract with MRC, it said you retire when you're 65. And I think actually a couple of years. So that's why I became emeritus. I retired, but I could hang on being emeritus.
Do you ever think about stopping?
Well, I don't want to stop at the moment because actually in my field I feel an awful lot of people have got things wrong, and I know what the right thing is. I could explain it very, very easily. When people look at there's a lot of structures of acetylcholine receptors now, and everybody uses a single particle method, where you isolate it in detergent and solve its structure. Well, and they get beautiful resolution, 2.4 angstrom resolution or whatever, and they write these papers, and everybody thinks it's great. But I look at the protein in the membrane and these tubes, and it has a different structure. And I know that's because it's cholesterol it's a complex with cholesterol, and when they put it in detergent, the cholesterol gets extracted, you lose it, and that alters the structure in the membrane. So although they make all these theories about how the protein works based on these really high resolution structures, I think they're all wrong, and I feel a strong urge to end up just with something so it's absolutely clear they're all doing things the wrong way. They need to see the protein in the membrane.
So at this end of your career, what would you define yourself as these days then? A structural biologist, a neuroscientist, or a bit of everything?
Yeah, I suppose a bit of everything. I'm not a neurobiologist in the sense that I have a sort of a more simplified view of things. I think I can't. I have difficulty with trying to understand all this connectomics. I don't quite. Well, time will say it might be just the right thing to do, but I suppose a reductionist. I think that the real things you should focus on at the moment is these things. Well, maybe it's good to begin them now, but you should really focus on understanding how nerve cells communicate with each other and how a single nerve cell works. So, in a way, I'm a cell biologist.
Yeah. Nigel, thank you very much for coming to talk to us. It's been really interesting.
Thank you very much.